Okay, I'm going to tell you all about arithmetic sequences. This is what I'm going to try to accomplish here. I'm going to tell you what an arithmetic sequence is. I'm going to find the nth term of that sequence. I'm going to tell you where this formula comes from, and I'm going to relate that formula to what we know about y equals mx plus b. We're going to graph it up. So, I have an example right over here. Find the sixth term. I'm going to move this over here. Find the sixth term of this arithmetic sequence. Now, an arithmetic sequence is just a sequence of numbers. And in this case, it is 3 and then 7 and then 11 and 15. And in any arithmetic sequence, you're adding by the same number or subtracting by the same number to get to the next one. And hopefully you can see here that in each case, we're adding 4. And that 4 is known as the common difference. I'm going to call that D for common difference. That is 4. And I'm going to erase this other stuff here because I hate when things are super all over the place and confusing. So we have this common difference of 4 in between each one. Now, it's asking here. What I also need to say is we have the what we call this in this arithmetic sequence. This is a sub 1 because that is the first term. This is a sub 2, a sub 3, a sub 4, and we're trying to find a sub 6. And in fact, I'm going to move this over here because I don't need that right now. I'll just save that. So we need, what's helpful to know is what is a sub 5 and a sub 6. Well, if we add 4 more to 15, we would see that this is, let's put this up with that. 15 plus 4 is 19, and 19 plus 4 is 23. So the answer to the question is, what is the sixth term? It is 23. Now, that's not so hard to do, but what if we're asked to find something else? What if we're asked to find the 20th term? What is the 20th term in this same sequence? Well, let's think about what's happening here because I'm a little bit too lazy to just do all of this, add 4 over and over and over again. Let's take a look at what's happening here. If I were to add, let's see, or no, not if I add, yeah, if I add 4 each time here, how many times did I have to add 4? I had added 4 1, 2, 3, 4, 5 times to get to the sixth term. I had to go 5 times to get to the sixth term. So if I had to find the 20th term, I would have to add 4 19 times. So I would get 4 times 19. Okay, and that would get me all the way over there. But I also have to realize here that I started at 3. So I would actually have to do 3 plus 4 times 19. Okay, well, 3 plus 4 times 19, I believe is, let's see, 19 times 4, I actually don't know, 6, 3, 76. Okay, so 76, and then 3 plus 76 is 79. So the answer should be 79. Okay, so really, that's all you got to do. But I want to relate this to this equation here. Now, this equation is given every time here. And it's classic. All the algebra classes and such, they all talk about this equation. Well, where's it coming from? Okay, let me explain this. The a sub n, that's, hey, a sub n, the n is the number of the term. In this case, n was the 20th term here. Okay, a sub 1, if you remember over here, I'm going to squeeze this in a little bit here so I can fit it all. But if you come back here, a sub 1, remember, was 3. A sub 1 is always your very first number in your sequence. Okay, so your very first number in sequence plus the common difference. Well, we found here it was 4 every single time. So that common difference was 4. And that's what I put right here, 4. So our very first number plus 4, our very first number plus 4 times the number term that you're trying to find minus 1. Remember here, I did what? This was the 6th term, but I had to do it 1, 2, 3, 4, 5 times. So you take that term, whatever you have, and subtract 1. Just like I was trying to find the 20th term, but I only had to multiply by 4 19 times because it takes care of the very first one, the very first term. So that's where this all comes from. All right. Now, and we use this when we're trying to find a large number term when we're too lazy to actually add the same number over and over again. Now, what I want to do is I want to relate this to ordered pairs. And I'm going to move this aside here. So I'm going to get to that a little later. But if I were to create ordered pairs, and the first number in the ordered pair would be the term number. So in our first sequence here, the term number, the first term. That first term is our origin, and I'm going to have to deviate just a little bit here and say that our first term is our 0 point. Our original value was 3. Okay, and I'm going to bring that up to this here and show you, maybe I could squeeze it all in here. So a sub 1, yes, but what I'm going to have to do here is I'm going to say originally we started at 3 and then 7 and then 11 and so on. So originally, or our 0th term is 0. Is 3. And then our first term that we applied the slope to. See, what we did not apply this difference here. Okay, but the first time that we did apply the difference, we got 7. So we didn't apply the difference, and then we did. So that is what's happening here. So we didn't apply the difference, but now we have. So the first time that we applied the difference, we got a value of 7. And then the second time we applied that difference, we got, what, 11. And then the third time that we applied that difference, we got 15. And we're going to plot these values now, and I have that plot. And I'm going to bring this over here. I have Desmos here. And these points here, I have 0, 3 right here, 1, 7, yes, 2, 11, okay, 3, 15, okay. And I'm going to try to make this a little bit bigger here and show you, get it straight, that as I bring this over, and I'm going to put this in front. I'm going to arrange this to the front. So now I have these points. And what we can see here is the first point right here. That's 0, 3. 1, 7 right there. 2, 11 right there. And 3, 15 right there. And they all end up on this line. And this line is denoted by that black line right there. Y equals 4x plus 3. And notice the parts. The 4 is the common difference, which is the slope of this line. And the 3 was our initial value. Our original value was 3. And so that's the y-intercept. Right there, the y-intercept. So when you're doing this right here, when you're doing this, when you're applying this arithmetic sequence, this is the y-intercept. This is the slope, and here's your x value right here. And it's all within y equals mx plus b. You've been doing this all along since Algebra 1. So I hope that all this has made some sense for you, and I plan on the next video being the summation of the elements of the sequence. So tune in for the next one. Thanks for watching.